Have you ever tried to imagine just how big our solar system is? We talk about planets being millions or even billions of kilometers away. And honestly, those numbers are so huge they can feel almost meaningless. It's like trying to picture a billion grains of sand. It's just a lot. But what if I told you there's a much simpler, more intuitive way to measure our cosmic neighborhood? A kind of celestial yardstick that puts everything into perspective. It's called the Astronomical Unit, or O for short, and it's the key to understanding the true scale of our solar system. So, what exactly is one astronomical unit? It's the average distance from our planet, Earth, to the Sun. Think about that for a second. We are, by definition, 1 O away from our star. This distance is about 150 million kilometers, or 93 million miles. Now, instead of juggling these massive numbers, we can use this one simple unit to measure everything else. It's like saying my local coffee shop is one home-to-shop unit away. It immediately makes sense, right? This is exactly what astronomers do. Earth's orbit becomes our baseline, our cosmic ruler. Let's see how this works in practice. Imagine you're drawing a map of the solar system. If we stick to kilometers, the numbers get out of hand very quickly. Mercury, the closest planet to the Sun, is about 58 million kilometers away. That's a big number. But Venus is 108 million kilometers away. Earth is 150 million. Mars is 228 million. And then you get to Jupiter, which is a whopping 778 million kilometers from the Sun. By the time we reach distant Neptune, we are talking about 4.5 billion kilometers. These numbers are just too abstract. Now, let's use our new ruler, the O. Mercury is much closer to the Sun than we are, so its distance is just 0.39 astronomical units. That's less than half of Earth's distance. It immediately tells you it's way in there, close to the heat. Venus is at 0.72 astronomical units, a little closer to us but still inside our orbit. We are, of course, at exactly 1 astronomical unit. Mars, our red neighbor, orbits a bit further out at 1.52 astronomical units. So, it's about 1.5 times farther from the Sun than we are. See how much clearer that is. And it gets even better with the gas giants. Jupiter, the king of planets, is way out there at 5.2 astronomical units. That means it's more than 5 times farther from the Sun than Earth. Saturn, with its beautiful rings, is at 9.5 astronomical units, almost double Jupiter's distance. Uranus is at a staggering 19 astronomical units. And Chile, distant Neptune, is all the way out at 30 astronomical units, 30 times the distance from the Earth to the Sun. Using the OW, we can instantly visualize the solar system as a series of nested orbits, with each planet's position relative to our own. It transforms a list of mind-boggling numbers into a clear, understandable map. This simple unit makes the entire solar system feel more like a neighborhood we can actually explore, at least in our minds. But where did this idea even come from? It's not like someone just woke up one day and decided on this number. The quest for the O is a fascinating story of scientific discovery that spans centuries. Early astronomers, even going back to ancient Greece, were masters of geometry. They could figure out the relative distances between planets. For example, they could determine that Mars was about 1.5 times farther from the Sun than Earth, and Jupiter was about 5 times farther. They had the layout, the blueprint of the solar system, but they didn't know the scale. It was like having a map without a UR hairpin or a scale bar showing what a centimeter represents. They knew the shape of the neighborhood, but not how big the blocks were. The big breakthrough came in the 17th and 18th centuries, thanks to a rare celestial event, the transit of Venus. This is when Venus passes directly between the Earth and the Sun, appearing as a tiny black dot moving across the Sun's face. Astronomers realized that if they could time this transit from different, widely separated locations on Earth, they could use a geometric principle called parallax to calculate the distance to Venus. And once they had the distance to Venus, they could use their existing knowledge of relative distances to calculate all the other distances in the solar system, including the most important one, the distance from Earth to the Sun, our astronomical unit. This led to massive international scientific expeditions. Astronomers like Captain James Cook traveled to places like Tahiti, all to get a good view of the Venus transit in 1769. By combining observations from around the globe, they finally pinned down the first reasonably accurate value for the O. It was one of the greatest collaborative scientific efforts of its time. all to find the size of our cosmic ruler. Of course, technology has improved a bit since the 18th century. In the 20th century, we developed radar. Scientists could bounce powerful radar signals of Venus and time how long it took for the echo to return. Since we know the speed of light with incredible precision, this gave us an even more accurate measurement of the distance. Later, when we started sending spacecraft to other planets, we could use their telemetry, the radio signals they send back to Earth, to nail down these distances with pinpoint accuracy. So, thanks to centuries of effort, the O is no longer just an estimate. Now, you might be thinking, okay, the O is great for the solar system, but what about everything else? What about the stars? That's a great question. And the O is actually the first step on that journey. It serves as a bridge to even bigger units of cosmic distance. The next step up on our measurement ladder is the light year. A light year is the distance that light, the fastest thing in the universe, travels in 1 year. It's an enormous distance, about 9.5 trillion kilometers. But how does the O connect to this? Well, 1 light year is equal to about 63,240 astronomical units. So our familiar Earth-Sun distance, our cozy little O, is the building block we use to conceptualize the vast emptiness between stars. It's the first rung on a ladder that takes us from our planetary backyard to the galactic metropolis. Let's put this into perspective. The nearest star system to us is Alpha Centauri. It feels close in sci-fi movies, but in reality, it's about 4.37 light-years away. If we use our O ruler, that distance becomes about 268,000 astronomical units. 268,000 times the distance from the Earth to the Sun. Think about that. The most distant planet in our solar system, Neptune, is at 30 astronomical units. The Voyager 1 spacecraft, which has been traveling away from us for over 40 years, is currently at about 163 astronomical units. It has a long way to go before it even comes close to leaving our Sun's immediate influence, let alone reaching another star. Using the O to describe interstellar distances paints a powerful picture of just how vast space is, and how isolated our solar system truly is within the Milky Way galaxy. Our entire planetary system, out to the orbit of Neptune, would fit inside a tiny fraction of the distance to our nearest stellar neighbor. It's a humbling realization, but also an amazing one. So, the astronomical unit is much more than just a random number. It's a beautifully simple, human-centric concept that tames the unimaginable scales of the cosmos. It starts with the one thing we know best, our own planet's journey around our star. From there, it allows us to map our entire solar system with clarity and then to take our first steps into understanding the immense voids between the stars. It's a testament to human ingenuity, from ancient Greeks sketching orbits in the sand, to the 11th century explorers sailing across oceans to watch a dart cross the sun, to modern scientists bouncing radio waves off other worlds. The O is our cosmic ruler, a fundamental tool that connects us to the universe. And it reminds us that no matter how far we explore, every measurement, every discovery begins right here with our connection to the Sun, 1 astronomical unit away. Thanks so much for watching. If you enjoyed this journey through our cosmic neighborhood, be sure to hit that like button and subscribe for more deep dives into the wonders of space. See you in the next video.